last time.
Yeah,
Good, good, good. Okay. So if you go to the practice test page, now the other midterms that we're missing are there. We're not doing it yet. But midterm number 2, we were thinking of doing Wednesday. Because Monday, there's no school, President's Day. We're finishing up the big section of Mad Science today. So it sort of makes sense to see how we do on Wednesday. Remember that on the midterm, your goal is first, not to embarrass yourself, and second, to get one of these stars for writing writing homework problems nicely. I will give you stars for those things. So when you write things nicely on Wednesday, then you can get 10 more things done from that.
So I don't have to.
You don't have to. You could earn those 2 stars with homework as they're sort of originally intended. But if you haven't done those yet, this is like a free opportunity in class to just write a little neatly and get credit for it. I'm not going to grade the midterm by how many things you got right or wrong. This is like we did for midterm 1, where you spend part of class working by yourself, and then you try and fix and finish things in groups. And at the end, I tell you what the answers are, and you want to make fun. That's what we're doing Wednesday.
We do it on Friday.
Friday of this week is similar but different. So first I just want to clear up Wednesday. That's what Wednesday is. And if you look at what midterm 2 is, it's all the stuff we've done. These are just the same problems. If you went to the homework section and looked at the random problems, all I did was sort of reformat the page so that the Mad Science ones are all together on one page, right? So there's nothing new here, nothing surprising. The one we'll do on Wednesday will look just like the one here, except I'm printing out a certain one of them instead of a random one. That way we'll all have the same one to talk about. Okay, questions about next Wednesday? Okay, then Friday of this week, I am out of town because of a kid gym meet that for some reason the host gym team scheduled on Friday at 8 in the morning on Valentine's Day. Who does that? So yeah, so much for his school on Friday and my little one's Valentine's party on school and my wife and I having a nice dinner or all of that. We will be going to a gym meet. But you will have class even though I'm not here Friday. And what I think will work well, I've talked to the sub about this already, is towards the end of the term, probably week 10, you need to take the no calculator test. It's the no calculator half of the problems, so you don't have to worry about on the final exam having a no calculator section. We'll just do this sometime in week 10 and get it done together. So you have studied all of this stuff already. And I'm a little worried that if we waited till week 10 to do one of these, then it would all go out of your brain because it's been a while. So this is good for several reasons. You can see this material again as review, so it doesn't fade away from your brain. You can work in groups, because this isn't the version that counts for your grade. That will happen later in the term. But this is the group work version. And you can explain things to each other, because you've heard me explain each of these kinds of problems a few times. And if it hasn't clicked, maybe have someone else explain it to you. And then there will be a different math teacher, Steve, who is up here. So when your group gets stuck and your group can't figure out the answer to number 5 or whatever it is, then there'll be someone else who will explain it to you in his way. And that might help you too, because again, if my way hasn't worked, you need some other way. So if you want to show off on Friday of this week, then go and do a practice one of these or 2, and then you can be on top of things. If you're busy this week, that's okay. You can just sort of rely a little more on your group members to help you. But if you have time to brush up, then you could show off on Friday. And it will be the same thing where towards the end of the 50 minutes, he'll pass out the answer key, and that way over the weekend, you can know which ones you need to fix up and which ones you got right and things like that. But it'll just be all group. We're not gonna have the pretend it's a personal test for the, because there's not enough time in 50 minutes to do it that way. So that will be good review, and I've double checked that there's a little bit of, can you multiply a 3-digit number by a 1-digit number, but there's nothing that's terrible for calculators if you do them right. If you do them wrong, you can make any of these numbers terrible, And that's a hint on the no calculator test that you're not doing it the right way. So that will be good review on Friday. And then when I see you a week from Friday, we'll start the new section just a little bit because it will be a short class. So, ta-da. If you wanted to run ahead, then I have now finished this website page. Everything here is ready for us when we get to it, but you don't care. So there we go. Okay, so that's the upcoming thing. So kind of a review day this week on Friday, and then the how much did I get out of the second third of the class when I see you on Wednesday. Question?
Is there a homework due Friday?
Everything has been due from the shapeshifting. For mad science, the only thing due is fractions because we still have questions on percentages. We had one at the beginning of class on Monday. So the very next thing I was about to say, excellent segue, you can get your tip after class, is do we have any questions on percentages before I go into measurement more? Anyone have percentage questions? Yes, which one?
Question 5
This question 5. This
and
is
question 7.
in the turn-in problems.
Yeah.
Okay, so now I can answer Andrew's question that no, there's no due date for this because we're still having questions on it. So turn it in if you can. Yeah, don't wait, but there's nothing about the turn it in on time achievement star for percentages yet. Other question or just stretching? Stretching. Okay. An investment increases in value from $200 to $216. I like drawing this kind of motion-y picture because it helps me see which is the original and which is the new amount. What is the percent increase? So our formula for percent change, anyone remember our formula?
I got the answer.
Percent change equals
Change divided by original, yeah. If you're not remembering that, then where is it? It was right there, percent change, click on that, and there it is.
Oh,
Yeah,
yeah.
let's stick that in the archived board work. Okay, so I need a change. And it doesn't tell me explicitly in the typed out problem how much the change is, but that's okay, I can see. The arrow needs a little one. There we go. Okay, so now I just plug it in. Oops, I'm making the mistake. I was going to warn you not to make. Keep track of which is the original. Oh. Yeah, pointer. Okay, my math is good, but I'm not done yet. Why aren't I done yet? Yeah, they asked for a percent, and it's not in percent yet. So right into percent. Or not. Question?
So I'm just wondering how I get 1.08 on the calculator because that is what I got.
If you did 216 divided by 200, you did new divided by original instead. It's not that 108 isn't a sensible thing, but that's the answer to a different question. That is, what is the new amount as a percentage of the old? rather than what is the change as a percentage of the original. Okay, and 10 you said?
7.
7. Okay, this one I think I'll change the numbers on. So I'm not doing all your homework for you. Let's make this just be 1,500. And I'll make this be 24%. So changing two numbers. So Bluebeard the pirate has a balance of 1,500 on a credit card. The annual percentage rate is 24%. And he has to pay at least $36.70 a month. How much less than this is the interest? So first I want to know what his monthly rate is. So his annual rate is 24%. How would I make that annual rate a monthly rate? No, that would make it just a decimal. It's still annual.
Divided by 365?
And that would make it a daily rate.
Divided by 12.
Divided by 12. Everyone see why? 12. Let me move this over a little bit. When you have a credit card, if it has a 24% annual rate, that means over the year, it's a 24%. Each month, you only pay 2% on what you are owing at that time. So that's why you got it wrong. Don't feel bad. That's just how credit cards work, and we haven't talked about that in class. Okay, so we want to do find 2% of 1,500. If you're forgetting this one, then that's where you go here and click not on percent change, but percent of, and it talks about multiplying. So So that's the amount of interest, because what we multiplied by was the interest rate. Last step. So he pays off, what does it say? $36.70. Of that, $30 is interest. So he has $6.70 of the balance paid off. So this is how credit cards make their money. They give you this minimum payment, and hopefully everyone has heard that if you can afford it, you should always pay off your credit cards as much as you can, not just the minimum payment. The minimum payment will cover the interest because the credit card company is needing to make their money and pay their employees and all of that stuff. And then they make it a little higher, so you're paying off a tiny bit of your actual debt, but not very much, because the credit card company doesn't want you to pay off your debt, because then they don't charge you more interest. Questions on that? So again, your turn-in problem will have different numbers, slightly different, but the process will be exactly the same. Okay, two good questions. Other questions about percents?
How about the more same thing, but the numbers? Like what?
With, so repeat it with yet another set of fake numbers?
Yeah.
Okay, we can do it again. Uh, What numbers do you want to use?
I don't know, 2,500.
Okay. More pirate debt.
And 33.5%.
Okay. Don't know of any credit cards that are actually that high, but I also don't know any pirates, so good enough. And I'm gonna change this one to 60. Just because I'm not sure with these other numbers bigger, if 36 is gonna actually be big enough to cover it. So. Okay, without looking at your notes, without me going back to the other slide, what was the first step we did? Yeah, so we take 33.5% annually. And did what? Divided by 12, good memory. So 33.5 divided by 12. So about 2.79%. I'm rounding in the middle, which is not a good idea, but I am also knowing that this problem will have an answer that at the end is rounded to 2 decimal places because we're going to do dollars and cents. So if I am rounding, then if I'm keeping 2 decimal places, I won't be off by more than a cent or two. So we're okay. Okay, step 2.
Multiply by 2,500.
So we take the, what is 2.79% of 2,500? Of becomes multiply. This one has a riplop. And whatever that is, divided by 100 times. So 69.79.
69.75.
60. Okay, I didn't actually round my thing here, so if we're different, that's why. Whoops, I don't want to box around it though.
Oh, yeah.
Okay, and I messed up. 60 wasn't enough. I was trying to make this bigger so that the credit card would get its interest. So let's say that it's a $75. Why is that moving? Minimum payment. So he has to pay off 75 bucks. Of that, 69.75 is interest. So how much of his debt does he actually get to pay off? It'll be 5 1/4. Good. Questions on this one? Then his minimum payment was 75. That's what he has to write the check for to the credit. No, because it's asking how much less than this he paid. So of his check, almost all of it is just paying the interest. And then a little bit is left over just to pay off his debt a tiny bit. Okay, good. Percent review. So our next thing will be polygons. So while I am talking, pass these around. If you are a kinesthetic person that likes doing things with your hands, then take some rectangles. Maybe 2, maybe 3, based on if you think you'll need an extra chance because folding is not in your skill set. Okay, so basic geometry stuff. The perimeter of a shape is the distance around the edges. If you are an ant walking around the edge of the table, how far do you go? The area of a shape is how much room the shape's surface is. If I was painting the table, how much paint do I need to cover it? So perimeter is something I could measure with string or rulers. It is a linear distance. Area is something that I can't just measure with the length of a string. I have to know how much space is being covered. We'll start with perimeter. And we're talking about polygons. So polygons are closed shapes whose edges are straight lines. So circles are not polygons because they fail the straight line part. What closed means is if I was to draw something like this, that's not a polygon either because it doesn't connect. If I drew something like this, then that would be a polygon. It is closed and all the edges are straight. Yes?
So a diamond would be considered a polygon.
Yeah, diamonds are polygons. So the kind of classic polygons we get are squares, rectangles, triangles, parallelograms. You can think of them as sort of a rectangle an elephant sat on, and trapezoids, which are sort of like a triangle where someone lopped the top off. So to make sure you understand, take out some scratch paper, use your notes. First, draw a polygon with 7 edges. Seven edges.
I'm not a good drawer.
You don't have to be a good drawer. If you are trying to make all of your edges exactly the same length, you are trying too hard.
7 inches.
So depending on how lazy you are, you could just do something like 1, 2, 3, 4, 5, 6, 7, right? As long as it's closed and has 7 lines, you're done. It doesn't have to look pretty. It doesn't have to.
Do you have an extra pencil?
Do I have an extra pencil? I probably do. Do I have an extra sharp pencil? You don't need to erase. Okay, 94. Draw a shape with 4 edges that's not a polygon. So polygons are closed and all the sides are straight. So either break one of those or both of those rules. So you could say 1, 2, 3, and then a curve. Or you could say 1, 2, 3, 4, and it's not closed, right? Or you could have lots of curves, whatever. But 1, 2, 3, yeah, whatever. That's not a shape. Okay. Eventually my artwork will become intolerable. Okay. So perimeter is the distance around a shape. And I really can't teach you about perimeter because you know how to add up numbers. The only thing that happens wrong is when people's brain turn off because they're having a timed math test, then they either miss a side or they double count a side. So my suggestion to you is to always pick one corner and just make some little mark that I'm going around from that corner. And then when you add it up, 5 and 4 is 9, 15, 23, 32, then you remember to stop and not double count them. But that's all it is, add up the numbers. I'm gonna make my little arrow a little more arrowish. Okay. The other thing that can be slightly tricky is if they don't tell you all the numbers. So what's the perimeter of the top triangle?
12.
12, yeah. 3, 4, and 5 makes 12. What's the perimeter of the bottom rectangle?
You just do the same as the other side, so you have 3 on the other side and then the 6.1 on the bottom.
Right, this is also a 6.1, this is also a 3. Some people will do this in their head, some will use calculators, it's all good. Some people will add these up first and double it. Other people will add 4 things. It all works. So, but yes, 6 and 3 is 9, 9.1 double is 18.2.
Would you have to change the 6.1 to like 61 or per se? Or
Because it is 6.1. Somebody measured it and it's that long and they're not allowed to change it because they measured it. So there's no percents, there's no riplop. There is one change that could happen, so great segue. What if you had someone that did a terrible job at measuring and they gave you this thing, that it's 2.5 feet and 20 inches. Now how would I find its perimeter? I have to make up my mind. Am I measuring this thing in inches or am I measuring it in feet? Because they are all over the place using both. So in this case, the problem is telling me use inches. So if they want everything in inches, but they were rude and gave me one of the numbers in feet, what's my first step? Yeah, if I multiply by 12, then 2.5 feet, 12 and 12 is 24, another 6 will be 30 inches. So then I can add it up and get 100 inches. You could also do 30 plus 20 is 50 times 2 if you're that kind of times 2 person. I don't think any of the test questions are tricky like this because it is more rude than tricky, but just be aware some of your textbook problems might be like this. Things in other math classes might be like this. The person who redoes your kitchen might be like this. Are we good so far on perimeter? Okay. There was a joke. When my grandfather turned 70, he started to walk 3 miles each morning. Now he's 75 and we have no idea where he is. So the problem is they might not label a side and you have to do a little effort to figure out what it is. So what is our missing side in this? 1 mile. Everyone see why? She took this one and that one and said, well, if that's half, then the rest of it must be 1 mile. Okay, that's as many ways as I can think of to be tricky with adding up numbers. There we go, you're good at adding. In general, there's the 6-step problem solving process. Make sure you know what you're looking for. We saw that with the one where, wait a minute, do they want feet or do they want inches? They're giving me both. often in these problems, especially with a nice textbook, we'll have the pictures drawn for you. If they're not, that might help to draw the picture. You often, for easy problems, don't need to name things, but that's part of the steps because sometimes you do. Maybe you want to know that this is the total width or whatever. Then do the math and check your answer. Okay. Now we're going to play with our paper. So you have a paper rectangle if you wanted one. The area of a rectangle is what we're starting with. It's length times width. And that's because if we were to break up the 4-foot side into 4 pieces and the 2-foot side into 2 pieces, then we'd make these 8 little squares, because 4 times 2 is 8. And this is an important definition because it's really a definition, not a formula. This is telling us what square feet means. Right? The square foot is exactly what it says it is. It is a square, and it's a foot on a side. And when I'm asking for the area in square feet, I am saying how many square feet does it take if I was to tile this as the bathroom with tiles that are 1 square foot. So don't think a square foot is just some random words used to label. It really means a square, that's a foot. So that's what we get. Length times width for the area of a rectangle, because that's how we're defining what square feet is. My first question is, here is a triangle with a right angle corner. How much does it cover the rectangle? So take your first piece of paper, and don't worry, there will be no origami on the final, but you want to fold this so that you get that kind of triangle. See how I'm folding? I'm going to leave this here and wander around and help people because
Okay.
It's not.
I don't know, he did it for me.
Like this, it just.
You wanna look at mine? He did it for me.
I'm in a little trouble.
okay. So all the way from this corner.
Yeah, that's what that's.
I did, but it's not really happening.
Okay, everyone who wants to do this has done this. So my question is, how much of the original rectangle does your triangle take? Half of it. And how do you know it's half of it? Good. Well, she's pretty sure. How is she sure that it's exactly half? Yeah. You can flip it over and you can't tell. You could rip them apart and put them on top of each other and they match. Something like that. So for this kind of triangle, we can see that the area is 1/2 of the length times the width. Because if I was to finish drawing things, then it's covering half of it. Why am I using cursive for my L and W? Because sometime back in my own math history, I got the problem wrong. Because I wrote an L that wasn't cursive, and I thought it was a 1 at some point in the problem, and then I messed up, right? So that's why I do cursive. With triangles, don't ask me why, I wasn't there. Somebody decided that we should call this a base and a height instead of a length and a width. So everyone memorizes 1/2 base times height. But it means the same thing, that if you were to finish drawing the rectangle, it's covering half of it. Okay, now we'll get a little harder. If you show the answer, then there you are for the people at home. Okay. Now we have a triangle whose top doesn't hit the middle and it doesn't go straight up. And here's our bigger rectangle. So make one of those. Either take your same paper or take another paper. Put your finger somewhere that's kind of random, not right in the middle, not a corner, and then fold from the bottom corners to wherever you picked with your finger. And again, I will wander around if you need help with the paper folding. And we're making that.
Is there a better way?
Is there a better way?
Like I'm in.
So here's your top. There. Okay. Is that yours has a flat top, so you can't do that. It's got to go from one of these corners.
I don't know, there's too many lines in it.
So, get a spot on the top.
Never in my
This one is
40
back.
years of life have I had to make it. I get confused with all the lines on it.
So how much of the original rectangle does this triangle cover?
Pretty much half.
Pretty much half. Okay.
So you're gonna give us paper for our test?
No. There's no paper folding on the test. Okay, does pretty much half mean you think it's close to half, or does it mean you think it really is a half and just don't want to commit?
Oh, well.
I will give you a hint. So here's the hint. Whoops, come on, hint. So we have that thing. What happens if I take this triangle and cut it off, which is why you have paper, and then move it?
Okay. That's not
Where do I want to put it?
in the back and then.
No. On the other side.
On the other side. So if I put it on the other side,
Does it make a spot?
then what happens?
Near the arch. I screwed it up.
Does that help convince you that your original triangle is half of the whole thing? Because if I flip it over, it's the same. So if you take this triangle a little bit, put the wing over here, then you get two things that are the same. Turn them over. Oh, which-
I think I read the wrong portion.
Okay.
That's
Okay,
okay.
I see it.
Let's look at it on the screen. If our folding isn't exact, then the screen is nice.
Yeah, there you go.
So there we go. Now it's pretty. So the green triangle is the same as this. So even when I move the top corner, and it's not directly over one side, it's still true that the triangle is 1/2 times length times width, or 1/2 times base times height, however you want to say it. And all of that means, again, is that the triangle is half of its original rectangle that was based on height. Now look at that. So why are we doing this? We're developing these formulas and destroying paper, not because we hate trees, but because you need to understand where these things came from. You're probably just going to memorize them. No one is going to ask you to recreate the formulas on a test, right? But when you memorize them, it's nice to know that, yes, they make some sense. It's not just that Pythagoras went up to Mount Sinai and somehow got the geometry formulas, but that, oh, okay, it's half of this rectangle. Maybe no one has shown you which rectangle it's half of before, but there it is. You can see it. So there we go. Okay, onward. Here's a parallelogram. Guess what? You're already holding a parallelogram, right?
Yeah.
So how much of the original rectangle is used up by the parallelogram? Don't think too hard.
Quarter?
Now, this whole thing is the parallelogram, and this whole thing is the rectangle.
3/4.
They're the same thing, right? I'm using my whole paper, whether I move this piece here or whether I
Oh,
move
so
this
it's
piece.
one paper.
That's half.
So it's, no, because we're looking at the parallelogram, so it's the same thing. So if I show the cute little picture, then the rectangle and the parallelogram use up the same amount of paper. It doesn't matter whether this little wingy part is here or here.
Is it the same?
It's the same area, yeah. So the colors are going to matter. So here we have what I'll call the height, and here we have the base. So the area is base times height. That makes sense? Because that is this rectangle. What that means is when you are measuring a parallelogram, you need to find that. So, oh, come on. So when I'm measuring the parallelogram, I have to measure the height and I have to measure the base, and the area is base times height. These diagonal lines are not part of the formula. Those are red herrings. Everyone know what a red herring is from mystery novels? So, yeah, it's a lot of, it's things that look like they're clues, but they're not. They're not part of the answer. So if somebody measures these diagonals for you, ignore that number. If they measure the base and the height, great, that's what you want multiplied. Because the amount of paint to cover this is the same as the amount of paint to cover the rectangle. All I've done is move part of my kitchen. So, okay, we've done three shapes. Rectangles were what we started with. Triangles, we saw that all triangles are half of the rectangle that surrounds them. By the way, I am lying. There are also triangles, oops, that look like, come on. They kind of stick out past their base. But I'm not worrying about those. You can think about those at home. Okay, so we started with rectangles, we did triangles, and parallelograms, just make sure you measure the right things. So the last one is a trapezoid. So for a trapezoid, you take two pieces of paper. And you're going to mark two different spots on the top. They can be looking symmetrical or not, it doesn't matter. And then you're going to fold down from each of those top spots to the bottom corner. So you get something like this that has a base and a top that are parallel and flat, and then two lines that are going down to the corners. Papers, if you need more paper, I can give you more paper. So, the magnet having you do this with two papers on top of each other is a hint. I want to take my two trapezoids and use them to make a shape I already have. And how can you put these together to make a rectangle, a triangle, or a parallelogram?
Put the bases together.
If you put the then that's something that still has six sides. I haven't done that yet. But that's not a rectangle, a triangle, or a parallelogram. Yes, you take one of them, you flip it over, doesn't matter which one, and then you bring them up close. Everyone sees that?
Kind of like playing tag.
So again, sometimes the floppy papers in the air is not the best way to do it. So if you like the pretty pictures on the screen, I'm taking a copy and I flip it upside down, and then I can make a parallelogram out of my thing.
Oh, so we don't care about this.
So, okay, this is the part that requires a little bit of concentration, even though it is still the lunch hour. So pretend you have food in your belly. We have a top and a bottom. I'll call them T and B for top and bottom. Since we're dealing with parallelogram, we know that these we don't care about, right? Whatever those diagonal things are purely distractions. Let's ignore them. What we need is the height. Yes, keep going.
And then that side to the.
So this bottom is the same as this bottom. And this little top is the same as this little top. So my area is going to be the height of this thing times the top plus bottom. Everyone with me so far? Now I have one more step. All I really want is one of these. But I photocopied it. There's two copies there. So as my last step, I need to divide by 2 because my answer is twice as big as it should be.
The paper just.
So here's the three parts again. We have the height times the big base, because that's what the parallelogram was. But it's actually twice as big as we want, so we do it divided by 2. So this formula you don't have to memorize. It's now gotten, I don't want to say it's hard, but it's just kind of, who cares? Right? By the time week 10 comes, we'll get this to you if it's on the test.
If it's on the
If
test.
it's on the test. Okay. So I don't know. It's random.
So it might not
You make
be.
this up?
Yeah, the test is random problems. I'll show you. So if you go to the test, yeah, tests.
Oh, just like the way.
Final. So there's a shape, right? I reload it. There's another shape. There's another shape. So there's a whole bunch of shapes. Yeah.
There's 35 questions on the final.
So it's about 3 minutes a question. You have 110 minutes. Okay, where were we? So this is an interesting formula. If you do want to memorize it, I encourage you to think about it this way. There's a name for taking two things, adding them up, and dividing by how many? What's the name for that?
What did you say?
When you take two things and add them up and then divide by how many things there are.
Let's find the average. There we go.
So the formula for the area of a trapezoid is the height times the average of the top and bottom. And that kind of makes sense. It's not like the top or the bottom is more special than the other. You're kind of using them equally. So we take the average of the top and bottom and multiply it by the height. If you want to memorize it, there you go. If you don't want to memorize it in real life, you don't need to, because you could always take a trapezoid and draw a line and make two triangles. So if for some reason you were making a doghouse shaped like this in your backyard or whatever, you can always turn trapezoids into two triangles and you know the triangle math. So in real life, if you were the one measuring things and cutting the wood, you don't need the trapezoid formula. But it can save you time compared to doing two different triangle problems. In real life, you can have someone else build your doghouse, I suppose. There you go. Okay. So here is a check to see if you understand things. Let me shrink it so it fits. Shrink more. Once more. I'm not going to say on this sheet that these are feet or inches or centimeters, whatever. Just count squares, right? But how many squares cover each of these shapes? So I'll take attendance while you stare at this. If you think you're done, talk to your neighbor. And you can either use the formula or just use the visual moving around wings that we talked about before. So doors here. Area, just area. Perimeter, I'm not worried about. Everyone can add up numbers. Taking attendance reminds me, one of your achievements is the one called Actively Healthy, where you are here for, I think it's 16 class days, and we've had 16 class days. So again, I know if that's you, but if that is you, then talk to me after class. We'll celebrate that you and your kids haven't gotten too sick. You get an achievement. Okay, questions? Like for this brownish one, all you're doing is the inside. Does that make sense? So what's our answer for the top red triangle? So this was 3 times 4. The whole thing is 12. So half of 12 is 6. Okay, how about the blue one?
I don't know. Sure.
So 6 times.
6 times 3 is 18, so half of that is 9.
Oh, okay.
How about the orange one?
4.
Is it the same?
5. 5 times 3.
Yeah, so the height is 3. The base is not 6 though, 5.
5 times
So
3.
5 times 3 is 15. There's no half, it's just 5 times 3. Because if I peeled off this yellow highlight pink bit and put it over here, I would just get 15.
Oh,
the rectangle, but that's
Oh, it's not a triangle, so, okay.
using my highlighty thing, it is this much, right? So it's just that 15. Okay, how about the brown one without the obvious hint on it?
3 and 3.
I don't have a brown, do I? Yeah, 3 and 3, so it's going to be 9.
Okay. I like that paper thing.
Okay, these are the same, because when I go to visit elementary school classrooms and actually give them printed copies of this, then they cut out one of them, right?
Yeah,
So
5 and
what is the purple area? Trapezoid area.
5 and 4.
So this is 4. And then the bottom is 5. The top is
1.
1. So take the average of 5 and 1. So 6 divided by 3, 6 divided by 3, but 6 divided by 2 is 3.
Why,
You take the average at the top and bottom, so add them up and divide by 2. 5 plus 1 is 6. 6 divided by 2 is 3. And then multiply that
5, 4.
by 4. 12.
Why did we divide it by 2?
Okay, that was
Oh,
that we did.
oh, yeah.
Bottom plus top divided by 2.
I wrote it down right. Not everything. Just those weird ones that have the base. The other ones like this. I mean, top. The base and the top.
Okay, questions about any of this?
I'm sure they will. My brain.
For now, we're just introducing you to the formulas. Hopefully, you can remember them better if you've seen how they happen. Okay, circle time. So we did polygons. Circles are not polygons because they have curved edges. I'm going to make this bigger. Okay, if I had a piece of string, which I don't, so I will use tape. Okay, I need a brave volunteer who has an arm. Okay, so we're going to take string and tape or whatever and make it as wide as her arm. As if I was to take a long needle and just make how wide her arm is. So the question is, how many of these would it take to go around her arm? Like each arm? Everyone makes sense? Understand what I'm asking? You would volunteer too. So with your coat, your arm is that wide. So if I was to wrap it around, how many times would I need this length, the arm width, to go around the outside? So that's an interesting question. Arms aren't very round. We could do it with heads also. If I had something that was as wide as ear to ear, and then tried wrapping it around your head, how many of those would I need to go around your head? Heads aren't really that round either. So the math name for these is that the width of the circle going right through the middle is called the diameter. I don't know why we need another word. Width is a perfectly good word, but diameter is circle width. And the perimeter for a circle, the distance an ant walks around it, is called the circumference. Again, perimeter is a perfectly good word. I don't know why we need another one, but we all have to memorize it. So, okay. So what we are asking is how many diameters does it take if you were to lie them out like string to go around the circumference? And there's an answer to this. So here's a cute little thing. Here is the width of our circle.
I like the little.
And if we were to take that width and unroll it from around our circle, it's a little more than 3. So when the ancient Greeks, who liked Greek letters because they were biased, decided that they needed an answer for this, they called it the letter pi, and there we go. And that's That's all that pi is. It's the answer to this question. When you unroll the circle, how many widths? A little more than 3. So there is a formula. Circumference is pi times diameter. Sometimes abbreviated C is pi times d. And that's all it's saying, is that the area around the circle is a little more than 3 of the width.
So it's the pi sign.
Yeah, the pi sign is.
If I remember correctly, the simplest form of pi was like 8.14.
It's the rounded form. It keeps repeating forever and ever.
Yeah.
So for practical carpentry, 3.14 is close enough. In this class, again, wonderful segue. Thank you, Daniel. Your calculator has a pi key on it somewhere. And this calculator, where is it?
What?
Where is my pi key? I go orange, second function, and then 3. There's my hiding pi key. So on mine, at second function 3, there's a little pi symbol. I don't know where it might be in yours. Do you want me to look?
I see it, but how do you use it?
I'll just do like 1 times pi and see if it turns into 3.14159, blah, 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 blah.
3.14.
Yeah, so if 1 times pi works, you're using your pi key correctly. So in this class, because we're at LCC and the math division has decided this, we want you to always use your pi key on homework problems. Don't round it to 3.14, even though that's probably good enough for building a doghouse if you had like a round.
But use that
Or-
whole number.
Then use your pi key. If it's pi times 9, do pi key times 9. Don't do 3.14 times 9. And that will get you in the good habit of not rounding in the middle, because you don't want to round in the middle. That is unfortunately not the high standard that the textbook uses. So there will be a few problems that when you look at the odd answers in the back of the textbook, their answers will be less accurate than yours, because they are rounding pi in the middle of the problem, which is a silly thing to do. So at one point in history, students had calculators, but calculators didn't have pi keys. So that's where this rounding business got to. But now we all have them.
What's the way to check
Try pi times 1. Because if that works, then there we go. You get 3.1415 times 3.
High school just gives pi.
I need to go. Oh shit.
Nobody.
Good discovery.
Yeah, so that's a long number. So you write that whole long.
Well, whatever the answer is, you'll round to the square foot or something like that. But just in the middle of the problem, when you're using pi, don't round.
Oh, that's
You weren't kidding.
Yeah,
Talk to the MRC. Okay, everyone okay about diameters? So this next part is kind of amazing. Okay.
Mine has rows, so I just started with the process.
That's it. Okay, that worked. So here is a small little square, and I'm labeling each side R. So what's the area of the square? R times R, so R squared. Then I take this square and I photocopy it 4 times. So I get this shape. So how big is this bigger square? It's 4R squared. And then I take that bigger square and I draw the biggest circle I can that fits in it. This little line, that's R, has a name. It's the radius. It's half of the diameter. And for a bunch of circle things, it's more convenient to use the radius than the diameter, either because in real life you'll have to measure half its R, or because someone else measures that for you, or back in the old-fashioned days, this is what you would set your compass to before spinning it to make the circle. So that was kind of a more natural number to use. Does everyone know what I mean by a compass to make a circle? So anyway, how much of the brown square, the 4R squares, does the circle cover? It looks like maybe certainly more than half. Maybe it covers about 3/4 of it, about 3 of those R squareds. Maybe it's a little more. So it just so happens that the answer is the same. The area of that circle is a little more than 3, that pi number, of those R squareds. It doesn't cover all 4 of them. There's extra bits sticking out in the corners. But it looks like it covers a little more than 3 of those 4 if you were to just do paint. So that's nice. That means our calculator can have the same pi key for an area formula and a circumference formula. We don't need like a pi key and a cake key or something like that. So that's the formula that we have here. Area is pi times radius squared. And that just means that if I was to paint a circle, the amount of paint is a little more than 3 times the amount of paint that it would cost paint to do one of those boxes. Okay. These are easy problems because your calculator does all the work, right? Here's a circle, radius of 2 inches. So we have circumference is pi times diameter. How big is our diameter? If you go all the way across, it's going to be not 2, but 4, right? So pi times 4. So take your pi key times 4 is about 12.6 inches. The general rule for rounding back from the very first day of class of week 1 was keep the same number of decimal places or add 1. And for these problems, usually you add 1 because pi is not estimated. It's pretty well known. And we're assuming that they're measuring this pretty well. So there we go. Then on the other hand, we have area is pi, and you could go times r squared or times r based on how much you like exponents. So in this case, it's going to be the same because 2 times 2 is 4. But my unit is different. This is going to be square inches. Because again, it's saying that if I had this square, it's covering, whoops, let me actually make it better. If I had this square, the ones that are 1 inch square each, it would take about 12.6 of those to cover. Some people write square inches like this. And if that's you, that's fine. But I'm, to be lecturing polite, going to use SQ period IN period. Just because if I do it this way, someone might mess up and put the squared next to the 12.6 as they're rushing to take notes. And it's not that we're taking the 12.6 and multiplying it by itself. It's just a 12.6. So this squared is part of just writing the label. And I don't want to have a chance that someone messes up because taking notes is not always easy. But if you like inches squared, that's great. That's fine for you. Okay, we have time for one more. Let's do that one. So circumference is pi times diameter. What's my diameter in this case? 1. So pi times 1, which will be about 3.1 inches. Area is pi times radius. So pi times, everyone okay with me changing 1/2 into 0.5 so my calculator can handle it? So that's about whatever it is, 0.79 square inches. So easy points on tests. All you have to do is plug things in and the calculator does all the work.
If you were to do it at 3.1, I ended up getting 30.5 or 30.1907054. The complete answer.
Yep, the rounding will be different. And these are kind of funny because there's no real life context, right? We're not sure if we're measuring something that's, miles of a field or small precise measurements for some machine shop project. So we're not sure how much it really matters how we round. In real life, hopefully it has some context. Okay, just a heads up of where we will going. Don't focus on this. If you want a challenge, do it now. But later on, towards the end of the whole term, we'll get these sort of puzzle problems where you have, here's part of a shape, and here's part of a shape, and how am I going to smash things together and so on. That's where this gets less boring. But we're not there yet. So if you want to work on this, go ahead, challenge yourself. If you want to just wait till we actually cover that, that's fine. And that's the end. You have finished Mad Science. Congratulations. You have 16 classes.
See you Wednesday.
Congratulations on being healthy.
I've
You
got
have
E16.
Yes, Michelle.
I said at the least.
Yes. I think Unique has had 16 classes, right?
No, I might take my son to the, playground.
I'll give it to you. And you, I'm gonna stop my recording.